Right. So Pythagoras' theorem, we looked at it a little bit before, but today we're going to look at it in detail. All right. So Pythagoras' theorem has to do with the right-angled triangles. All right. It does not apply to non-right-angled triangles. Anybody knows Pythagoras' theorem? Anybody knows? Anybody remembers what it is? The Pythagorean theorem. Josh, remember any of it?
um to find angles of a certain shape.
Well, it has to do with right angle triangles alone. Okay. Anybody else? What about you, Joshua? Do you recall anything about Pythagoras' theorem?
I honestly, yeah, I,
Oh, I can't hear you at all. Wait, that could be my
I
end.
said I forgot.
Are you all hearing
Hello?
me well, by the way? Or am I like delayed or anything like that?
We hearing you well.
Okay.
Hi, you will.
Okay, cool. All right. Zayn,
Hello.
have you done Pythagoras' theorem as yet?
No less.
No? Okay. All right, guys. So this is a right angle triangle, and all of you know what a right angle triangle is, I'm sure, because you've seen it many times before. A right angle triangle has one of the angles in the triangle is an actual right angle, right? So Pythagoras Pythagoras' theorem has to do with the right angle triangle. Pythagoras was a Greek mathematician from many, many, many years ago, and he came up with this theory, all right? And it's basically, now you see this side of the triangle, let me shade it in a different color. This side of the triangle here, that is opposite the right angle. Pythagoras' theorem. Well, oh, sorry, that side is called the hypotenuse of the right angle triangle, right? The hypotenuse is the side that is opposite the right angle. And that's how I want you to remember it. The side that is opposite the right angle. There's another interesting fact about the hypotenuse, and that is it's the longest side in the right angle triangle, right? So the hypotenuse is the side opposite the right angle, and it's also the longest side, right? So it's the longest side in the right angle triangle, all right? So Pythagoras' theorem has to do with the relationship between the hypotenuse and the other two sides of the triangle. So by Pythagoras' theorem, what he came up with is now if this the hypotenuse, sorry, let's call it A, right? And let's call this other side B and this side C. Pythagoras' theorem says that the square of the hypotenuse, so a squared, is equal to the sum of the squares of the other two sides. So that is the relationship between the hypotenuse and the other two sides in the right angle triangle. And we can use this theorem to find any of the other two sides of the triangle when you're given. If you have two sides, you could find the third side in any right angle triangle using the same rule that the square of the hypotenuse is equal to the sum of the squares of the other two sides. Right? So a squared is the hypotenuse, the hypotenuse squared. B squared is this second side, and C squared is that third side. All right. And like I said, you can use this one rule to figure out if you have A squared and C squared, or if you had B squared and A squared, you could figure out C squared, right? So from this, you get, by just rearranging the formula, you can find out what B squared is or even what C squared is. Because if A squared is equal to B squared plus C squared, then if you rearrange the formula to make B the subject, A squared minus C squared will be equal to B squared. And likewise, A squared take away B squared will be equal to C squared. So this is really what you need to know. The main theorem, which is that the square of the hypotenuse is equal to the sum of the squares of the other two sides. And by simply rearranging that theorem, you can make any of the other sides the subject of the equation, right? So let's put this in practice to see what it really is. All right, let's look at another right angle triangle. Don't worry if you didn't get to copy down what I just wrote. The most important thing there is A squared is equal to B squared plus C squared, where A is the hypotenuse of the triangle, right? I will send this note after class anyway, so don't worry about it. All right, so say we have this right angle triangle here, right? And let's say this side is 6 centimeters and this side is 8 centimeters. And I want to find out the length of this side A, right? Well, by Pythagoras' theorem, and anytime you're using the theorem, you need to state it, right? So you could say using Pythagoras' theorem or by Pythagoras' theorem, however you wanna state it, but make sure to state that that's what you're using. So by his theorem, the length of the hypotenuse, which is represented as A squared would be equal to 6 squared plus 8 squared. The square of the hypotenuse is equal to the sum of the squares of the other two sides. So therefore, A squared is equal to 6 squared, which is 36, plus 8 squared, which is 64. Therefore, A squared is equal to 36 plus 64, which is 100. And so A would be the square root of 100. So A is therefore equal to 10. All right? So this is how you would find 10 centimeters because it's the side of the triangle. All right? Let's do another one. And then each of you are gonna do one with me. All right? So let me just try to be a little lazy here and copy this over because I don't want to draw another one. Right. So let's say we had another one, and if this is 3 centimeters and this is 4 centimeters, what is the size of, let's call this X centimeters? Right? Now, it doesn't matter. You could name it whatever you want. X, A, B, C, theta, alpha, any symbol to represent that unknown side. Again, by Pythagoras' theorem, remember to write it. I'm not going to write it just because of time, but remember to write it every time you're solving it, right? So by his theorem, x squared, because that's the hypotenuse, is equal to the sum of the squares of the other two sides. So x squared is equal to 3 squared plus 4 squared, which means that x squared is equal to 3 squared is 3 times 3, which is 9. 4 squared is 4 times 4, which is, oops, I put 25 by accident, 16. And therefore, x squared is equal to 9 plus 16, which is 25. And so x is equal to the square root of 25, which means x is equal to 5 centimeters. Okay? Next, so let's do some together. All right, so I want you to make a note of what the theorem is. Soraya, you and I are going to do the first one. Ready?
Yes, miss.
Okay, so let's look at. Oh, by the way, do you guys get to use calculators as yet?
Yeah.
Yeah, you should, because you're in Form 3 now. Yeah. So you might need your calculators for some of these, right? Because not all of them would be like proper square numbers. Some of them might have decimal places. So if you don't have your calculator with you, just go get it quickly. Or if you have your phone, you could use your phone calculator as well. Okay, so are you ready?
Yes, miss.
So I would like to find this side labeled X. And the two given sides are, let's say this side is 5 centimeters and this side is 12 centimeters. Okay, so tell me, Soraya, what would be the first line?
The first line would be x equals 5 squared plus 12 squared.
Well, x squared, because it's the square of the hypotenuse, right? So x squared is equal to 5 squared plus 12 squared. Yeah. And then what?
And then x squared equals 25 plus 144.
That's right. Mm-hmm. Then what's 25 plus 144?
169.
Good. So therefore, x is equal to what?
The square root of 169, which is
That's right.
13.
Which is 13, right? So x is the square root of 169, which is 13. You'll see how I write out my solution step by step, not leaving out any lines. All my equal signs are under each other. That's how you need to write your solution, okay? Okay, Zane. Zane, can you do one with me, love?
Yes, miss.
So let's say we have this one is gonna look a little different because I realize I keep using the same triangle. It doesn't even matter what the triangle looks like. It's just that you just have to know which side is the hypotenuse and to identify the hypotenuse. Don't think of it just as the longest side of the right angle triangle, though that is correct. Think of it as the side that is opposite to the right angle. All right, so we just connect this. Good. Okay, so this one, let's say this is the hypotenuse here. Let's call it C, right? And this side is 24 centimeters, and this side is 10 centimeters. Okay, Zane, what would it be?
C squared is
Uh-huh.
equal to 24 multiplied by 10.
24 squared plus 10 squared. The sum of the squares of the other two sides.
Okay.
Yeah. So,
Then C
mhm.
would be equal to
Do you have your calculator
500,
with you? Oh, sorry. Sorry, honey. Go ahead.
536
Mm-hmm.
plus 100.
576 plus 100, yeah.
That would be 676.
Beautiful. So then C would be
And
equal
then
to
26. Yes. Square root of 676 is 26.
thank you. Beautiful. So C is 26 centimeters. Safira, hi.
Hi, Miss.
How you going, love?
I'm good.
Are you ready to try one with me?
Yeah, and coincidence, I actually did this today.
Oh, wow, good.
Well, I didn't
Okay.
like do questions. I like learn about it.
Yeah, nice. Okay, great. What a coinkydink. All right, hold on, let me draw it quick. Faith, I got your message and I was so busy this week that I forgot to respond, girl. I'm so sorry. And literally only when I saw you pop in class here, I remembered you. I'm so sorry, Faith. Did you get
No
through with
problem.
it?
It's not due yet. So
Okay, good. So I could still help you.
yeah,
Okay,
due
great.
tomorrow, I think.
Okay, great. All right. Well, after class, I'll look at it quickly, right?
Thank
Okay,
you.
you're welcome. Safira, let's do this one.
Okay.
Oh, do you want to see this how to write it from before? Or you remember?
I remember. I remember.
Okay, cool. All right. So what's the first line?
The first one will be x squared equals to 16 squared plus 12 squared.
Beautiful. All right. And then the second line would be
It'll be hold on, let me see. It'll be 256, I believe.
yeah.
And 144.
Yeah. Okay.
Mm-hmm.
So what would that be?
That'll be 400.
Mm-hmm. So x squared is 400, which makes x what?
I think is well, square roots of 400, and it will be x equals to 20, I
That's
think.
correct, right? So if x squared is equal to 400, then the square root of 400 will be what x is, because remember, to square something means you multiply it by itself. So 20 times 20 is equal to 400, which means x is 20. Okay, now the other ones are not going to have like whole numbers, right? These are not going to be square numbers. So you're going to have to use your calculator and actually just round your answer to one decimal place for me. All right, Joshua, let's begin with you.
As this.
Okay, so let's say this is 5 centimeters and this is 8 centimeters. Okay, Josh, let's go. And we need to find the hypotenuse here labeled x.
X squared
Mhm.
equals 5 centimeter squared
Yeah,
plus 8 centimeters,
good.
right? And then x squared plus 25
Mm-hmm.
plus 64.
Mm-hmm.
And then x squared will be 89.
Good. All right, and then
And, and then yeah,
all right, so after
x
one
squared.
decimal place.
Oh,
Yeah.
wait, I didn't get any for I got about 89.
Square root of 89. Try again. Still got it next?
I got 9.433.
Yes. So if we round it to one decimal place, it'll be 9.4, right? Because it's 9.433, blah, blah, blah. So to one decimal place, 3 is less than 5, so you don't need to add 1 to the 4, so it'll just be 9.4 cm. Round it off to 1 dp. Good. Thank you, Joshua. Faith, let's do one.
Yeah.
Cool. So this one we have, let's say this side is 4 centimeters, and this side is also 4 centimeters. Okay, and let's find the side labeled x. So let's find x. Okay, Faith, what's the first thing?
X squared is equal to 4 squared plus 4 squared.
Good. Hi, Jemiah. There's no problem, love. We're looking at Pythagoras' theorem today. All right. Yes, Faith. Next line.
4 squared is equal to 16 plus 16,
Mm-hmm.
which is equal to 32.
Yeah.
And the square root of 32 would be 16, which is x is equal to 16.
No, babe. The square root of 32 is not 16. The square root of 16 is 4.
Sorry.
The square root of 16 is 256, I think. I mean, not the square root of 16, sorry. The square root of 32, the square root of 256 is 16. So it can't be that the square root of 32 is 16, right? 32 divided by 2 is 16. The square root is something different. The square root is the number that when you multiply by itself, you will get 32. 32 is not a square number, so this number will not be a whole number, right? You'll have to use your calculator to find out what the square root of 32 is. Do you know how to do that on your calculator?
Yeah, I found it. It would be 1.0, so it would be 1.
No? Did you check the square root of 32 or the square root of 16? What did you check?
Oh, sorry, I pressed the wrong number.
Oh, okay.
The square root of 32 is 5.7.
Yes, right. And it's 5.7 rounded off to one decimal place because the full answer is 5.656, etc. And if you're rounding off to one decimal place, you look at the digits after, and if it's 5 or more, you'll add 1 to this place. So that's how come it is 5.7. Right? Now, let me tell you how you could figure out an approximation of the square root without actually working it out. Right? Now, you might not be able to figure out the exact number, but you could figure out the range that it would be in. So if you think about the square numbers, right? So 1 squared is 1. So the square root of 1 is 1, right? 2 squared is 4. So the square root of 4 is 2, right? 3 squared is 9. The square root of 9 is 3. 4 squared is 16. The square root of 16 is 4. 5 squared is 25, which means the square root of 25 is 5. 6 squared is 36, which means the square root of 36 is 6. 7 squared is 49, so the square root of 49 is 7. All right, so we are trying to determine what the square root of 32 is. And if we look at the square numbers, you just have to look to see which two numbers is 32, which two of these square numbers is 32 between? Anybody answer me? Which two numbers is 32 between? Which two of these square numbers? These are your square numbers here. 1, 4, 9, 16, 25, 36, 49, etc. Right? Between which two numbers will you find 32?
25 and 36.
Correct, right? So between 25 and 36, you will find 32. All right. And that means that the square root of 32, right? The square root of 32 would also be found between 5 and 6. And as you can see, it's 5.7. It's approximately 5.7. So this is how you can determine, and sometimes in CSEC, you could get a question like this in multiple choice, right? This is how you will determine where the square root lies. So like they might give you a multiple choice question and they'll ask you, for example, what is the square root of 32, right? So the square root of 32 is, and you'll have a few options. A, 16, B, 8, C, 5.67, or D, 4, right? And you would be able, for the multiple choice paper in CSEC, you don't have a calculator, so you actually cannot work it out on your calculator. But you would have to use what you know about square numbers and their square roots to figure it out. Because these square numbers, so what you think about is you think about where is 32, where does it lie in terms of the square numbers? And when you figure out where it lies, you would be able to approximate what the square root is, which in this case is 5.67, because the square root of 32 would be somewhere between the square root of 25 and 36. All right. So, Josh Perez, are you there?
Yes, Miss.
Tell me what do you think the square root of 15 will be? Between which two numbers?
Between 3 and 4.
Yeah, right? The square root of 15 is between 3 and 4. Excellent. Zane, where would you think the square root of 20 will be?
Square root of 20.
Yeah. Where do you think it will be between? Between which two numbers?
4 and 5.
That's right, between 4 and 5, right? All right. Soraya, Soraya, you there, babe?
Yes, Miss.
What do you think the square root of 70 would, where do you think that would be?
That would be between,
It's not listed here. You have to actually think about it.
it'll be between 8 and 9,
How come?
because 8 times 8 is 64, and
Uh-huh.
9 times 9 is 81.
Good. Um, Jemiah, where do you think the square root of 114 will be? Jemiah, you there, honey?
Yeah, I was thinking.
Okay.
Miss 11 and 12.
Between 11 and 12. Not between 11 and 12, because 11 squared is 121, right? So 114 is less than 121. So it would actually be between 10 and 11, because the square root of 100 is 10, and then the square root of 11 is, the square of 11 is 121. So it will be between the 10 and 11 instead, right? Okay, so let's take a short break, right? Just 10 minutes. We'll start back at 4:50. When we come back, we're going to look at some more questions like this, not the square root, on Pythagoras' theorem. Okay. So let's say we need to find another side of the right angle triangle when given the hypotenuse and a second side, sorry, and we need to find the third unknown side. Good. So we have a right angle triangle here, and let's say the hypotenuse is given to us. Let's say it is 8 centimeters. And then this side here is 5 centimeters. And I want to find this unknown side labeled x. All right. As we know, the Pythagoras' theorem is that the sum of the square of the square of the hypotenuse is equal to the sum of the square of the other two sides. Okay, so by his theorem, it would mean that x squared plus 5 squared, because those are the squares of the other two sides, is equal to 8 squared. If I want to make x the subject, well, I'll just move 5 squared to the other side. So if x squared plus 5 squared is 8 squared, then x squared is equal to 8 squared, take away 5 squared. So that means that x squared is equal to 8 squared, which is 64, take away 5 squared, which is 25. So that gives me 39. So x squared is 39, and therefore x will be the square root of 39. So x is equal to 6.3 centimeters taken to one decimal place. All right, guys. So to find the third side, when given the hypotenuse and another side, you basically just subtract the other side, the square of the other side from the square of the hypotenuse. But I showed you it in context of the Pythagoras' theorem, so that you don't have to try to just memorize these things by heart. It's math. So you could rearrange the subject of a formula to find what you're looking for. All right. So let's go, Jemiah. Jemiah, you
Yes,
there?
miss.
The one together, hun. Okay, so okay, Jemiah, let's go. And we want to find the side labeled X.
Okay. So this is x squared plus 6 squared
Hmm.
equals 10 squared. Then x squared equals 6 squared plus 10 squared.
It will be X squared is equal to 10 squared, take away 6 squared, because I'm moving plus 6 squared to the other side of the equation, so you'll now have to minus it.
Okay.
So it'll be 10 squared, take away 6 squared. Let's go.
And then we have 100 take away 56. 64.
Yeah. So that would make X what?
Um, 64.
The square root of 64.
Oh,
If x
oh,
squared is 64, then x will be the square root of 64, which is 8 centimeters. Let's do another one. You and I again.
okay.
Okay. Let's go.
X squared plus 12 squared
Mm-hmm.
equals 15 squared.
Perfect. Good.
Then X squared equals 15 squared minus 12 squared.
Beautiful. Fifteen squared is
225.
yeah. And 12 squared is 144.
Mm,
So this would be
111.
no 225. Take away 144. Isn't it
Oh,
81?
I, I write down 114.
Oh, okay. Is it 81 though? 225. Take away 144.
Yes.
Good. So then x is the square root of 81, which is 9. Okay. All right. Let's see. I'm gonna do a little vibe check here to see how we all going with it. So let me see.